Well, hello everyone, it's Nono here, and I want to welcome you one more week to the live stream. So this is the Nono.MA live space in which we weekly meet to reserve some time to do things that have to do with creative coding, machine intelligence, art and design, and a lot more things. This is live stream 32. If you're new, I'm Nono Martinez Alonso. I do this and do the Getting Simple podcast and do some writing online and some sketches. You can go to Nono.MA if you want to learn more. And with that, I would like to ask you if you can hear me and if you can see me okay. If the live stream is working properly today, there have been a bit of things to troubleshoot. And we're going to briefly see what we're going to take a look at today. I have my remarkable tablet here. We're going to do some conceptual thinking and some hands-on coding. And we're going to get started really soon. Again, for those of you who are connected online, you can use either the YouTube chat to talk or to ask or to write comments. If you're watching offline, you can leave those comments on the video comments. And you can also go into the Discord server, which we'll show the invite for later if you're not there yet, and go to the live chat channel. All right, again, just let me know on the chat if you can hear me, if you can see me okay, and we'll get started really soon. All right, so really quickly, one thing that I'm gonna do, I'm gonna just put here the do not disturb mode so my calendars don't show up there, and we're going to get started. All right, a reminder, as always, really quick reminder, like the video to support the channel and the work that I'm doing here with the tutorials, and subscribe if you want to get notified when I go live next or when I upload new videos. If you click on that bell and click on all notifications, you'll get a notification when I go live and also when I upload new videos. Otherwise, YouTube will send you random notifications if you have them activated. If you select none, you'll be subscribed to the channel, but you'll have to go to the subscription tab to see my videos. You won't get any notifications. You can join, as I mentioned, the Discord server or community at Nono.MA/Discord. There's also a QR code at the top right of the screen. And last week, we took a look at Lobe AI and Tensorflow JS. We're editing some of those videos. They'll be dropping on the YouTube channel day by day. And hopefully we'll get the Lobe web bootstrap React template video that I recorded last week edited in a way that you can digest it in case you didn't see it, or just to revisit it in a more fluid way. All right, the Bytes intro is a new episode, the latest episode on the Getting Simple podcast. You can go listen to it now. Co-host Asid Barbar and I talk about concepts at the intersection of digital technology and culture in a language that hopefully we can all understand. And as always, you can submit an audio question related to the topics that we cover on the podcast if you go to gettingsimple.com/ask. And I'll be really happy to hear your questions and hopefully make episodes answering them. All right, as always, what are we going to do today? Let me just check. Hi, Bea. Nice to see some familiar faces. And hi, Fabian. Nice to see you online. Thanks for letting me know that you can hear me okay. Today, we're going to take a look at TensorFlow JS, Pix2Pix, and AI drawing, maybe. As always, this is not like a closed contract. We have many things that happen along the week, and I don't know what we're gonna see exactly, but hopefully we can also take a look at a problem that Fabian posted on the Discord server, and that I would love to give some thought here just to see if it is what Fabian wanted to do, and also because this is something that I've been thinking of testing for a while now, to build our own image classification search system so we can query things by labels. All right, so this is a cover for a video that we already recorded, the cover intro. What are we gonna do here? So I'm not sure I'm not sure if this is something we're gonna have time today. So Fabian says on the chat, I'm the one who wants to know how you can get the image classifier opposite, like the text inserting and getting an image. All right, so yeah, we have Fabian here live, and let's see how that goes. All right, so let's get coding. So if we do a tutorial, maybe we can make right now, we can make a cover video, so a cover for that video. So let's copy this slide here and let's edit this title. So we'll put here how can we call this thing? So query images by image classification labels. Query images using a querying images with text, querying images with text using an image classifier. I'm not sure, this is like query images with text. Right. Let's try this one. All right, so let's see. So again, this is gonna be an intro for a video that we're going to record today live, and then we'll edit post-process for its release as a video tutorial. All right. Hi everyone, it's Nono here, and we're going to see how to query images by using image classification labels. This means, oh, I didn't put this thing. All right, let's try again. Hi everyone, it's Nono here, and we're gonna see how to query images by using image classification labels. That means inputting text and retrieving images that have been classified with certain tasks. Stay with us if you want to see the conceptual approach we take to this problem, and also how we try to do a hands-on implementation with Tensorflow. All right, so let's get coding. All right, so that's my title, and we'll have to edit that. And now, so I'm gonna make sure that I have the right noise print, so we don't have noise behind the audio of this tutorial. And I'm gonna do something that we've done on previous tutorials, and it's been pretty well acclaimed or successful in some way. So I'm going to get this thing here. So I have, let me see if I can see it. Let's see, we can see this thing. So I have here with me the Remarkable tablet. So this is a tablet with a pen that is sort of like an iPad that can only do one thing, which is writing and drawing. Or, I mean, you can also read books and read PDFs and annotate things, but mainly it's just for writing and diagramming and things like that. So in here, so if we, I'm not gonna show this right now, but if I click here on live view, so this is saying that it needs, so there is a live view beta feature that allows us to connect to the canvas in which I'm drawing from the application, not able to upload file. So live view is on. So I have here the So I have here an application that so let me see if I can, if I can get this right. So we should be able to put the live mode here on the application, and right, so turn live view off. Let's see, let me just see really quickly. Turn live view off, live view disconnected, live beta, live is connecting. Let me just check if we have any updates. All right, so what we get here, let's do it quickly. So we get this accept, oh, you cannot see, bro. Accept live view request, right? So I'm gonna go into the right of my screen and say accept. And what we have here now, live view is on. So as I draw here, I'm gonna draw a circle and another circle and another circle. We can see that, or you can see that on the screen, right? So with this, we're gonna start our conceptual approach to this problem. All right, so yeah, and it doesn't, it's not the best in synchronizing, but we're gonna try. All right. Okay, so today is 2021. It's the 20th of May, and this is live 32. Okay, so we're gonna take a conceptual approach to this problem, which is, we're gonna try to make clear the problem that we're stating. And we're going to, so if I zoom into here, I can see that the screen is going up to here. All right, up to here. And on the top, you can see everything. All right, so we have this thing here, which is a dynamic canvas. I'm sketching with my hand. And we're going to try to get to this problem. All right, so when we have, let's say we have a set of images, right? So we have a set of images that, we know what they are, but they might have really weird names. And, there are pictures that maybe we took with our phone, or we just found online, and here I have two pictures, but we could think of folders that have like many of them, right? So we have like thousands of pictures, and of course, it's easy to classify two of them if you have the time and it's just two, but if you have thousands of them, then you don't want to do that manually, right? And even if you wanted to do that manually, then you need a system to retrieve it. So when we have an image, right? So let's say image 23 PNG, we can pass that through an algorithm. So let's say this is a classifier, right? So like classifier. And what this is going to do is it's going to actually tell us whether this is, I don't know, let's say that like a dog or a frog or a cat or a horse. And then with that tag, we could say, okay, let's put that into, I don't know, like maybe a separate folder, right? So we put it on the dogs or maybe on the horses folder. And once you have that there, you can easily retrieve them because they're inside, right? So they're inside that folder. So a query system, really easy query system, for example, could be if you want a dog image, right? You just go into the dogs folder, right? So you have to, for this, you have to actually label the entire data set and split it in different folders. And then later you'll be able to, let's say, retrieve the images really easily. All right, so let's actually, let me see if I can actually delete things here. So if I do this, does this delete or not? It doesn't delete here. Why not? All right. So we can, we can go here. We have more paper space. And what we're going to try to do, the first thing we're going to try to do is get an image, right? So it's going to be a PNG or a JPEG. We're going to get it through a classifier. And this classifier is going to take one image, and then it's going to spit zeros and ones for many labels. So if this is a dog, it will spit 1 for dog, right? So we have this this image goes through a classifier, and you can imagine that this is a neural network. We're going to use something that is done off the shelf, and it's going to spit those classifications, right? So we can say, okay, this is a dog. And what we're going to do after that is we're going to generate a JSON file. So we're going to generate a JSON file corresponding to that image. So we're going to say, okay, we have 001.png. We pass it through our neural network. We get a set of labels, and then we will have a an array, let's say, with the labels that we have received, right? So this is, I think this is fairly doable. And to get more, let's say, technical about this, we could say we can use so TensorFlow JS, and we can use maybe MobileNet or ResNet. Those are two neural networks that are available on TensorFlow Hub, right? So yeah, so that's what we can do. This is an approach that I think is doable. We have kind of summarized here what we intend on doing, and yeah. So now let's prototype. So let's try really quickly here. I don't know if I can see more pages. All right, so let's just go behind here and leave some room here where we've written our approach for how we're gonna do this. And right here, so the steps here are all right. So first we're going to so first we're going to write a TypeScript classifier. Second, we're going to save labels to JSON. And third, we're going to search images by tag, which is text, and confidence, which is a float number. All right, so all right, so so Fabian, we have here. So this is to take out of the live video. Okay, so for the editor, right? Fabian is asking if this can be done with the Create ML tool. Does that also work? Yeah, that also works. And the difference is that here we were going to see how to do that with TensorFlow JS in TypeScript and TensorFlow JS, right? And TypeScript. We could try to do it in Swift UI. So it's 7:30. Swift UI and Create ML, but I'm gonna do it first with TensorFlow JS just to see the approach, And if we have time today, maybe later we can take a look at Swift UI. But for now, so we continue now with the tutorial here. All right, so we have our approach. So let's get started. Let's write so our markdown file here. So for 32.md, I'm going to, let's see, all right, where is this? All right, so this is gonna be querying images, and we can also take this out of the tutorial. Querying images using image classification labels. And the steps are, so first we're going to classify images with TypeScript and Tensorflow JS. Second, we're going to save labels as JSON. So per image. And then the third step is going to be query images with, so by label and confidence, right? So those are our steps, and we can, we can have that here. So we're gonna print that file, and that's our guide for today. All right, so we'll leave the remarkable tablet here, and we're gonna start actually coding. All right, so the first thing we need to do is create a new folder, so for a new project, and I'm gonna do that right now so I can get this here. So we're gonna go to the live stream. So if we do git remote get URL origin, we see that this is the at github.com/nonoesp/live. You can find the source code for previous tutorials there. We're going to make a new directory for, so here you can see the directories are padded. So we're going to make a new directory for 0032, and we're going to enter it. And then we're going to make a directory to, how are we going to name this project? So let's see how the other one was named. So, all right, query images by label by classification label TensorFlow JS. All right, so we're gonna enter that directory, and now we're gonna open this directory with Visual Studio Code, so which is my editor of choice. You might have yours. I don't know if you're still on Atom or Sublime, but this is mine. All right, so we're going now to create an npm project. So I'll do npm init y, so to respond yes to everything. So it just creates a default template text to image API. All right, so we have a live suggestion for the title, so text to image API. I like it. It's more catchy than my title, I have to say, query images. So we can actually move that. So query, so text to image TensorFlow JS. I like that one. So we're gonna open that on Visual Studio Code. So we have it here. We're gonna close this other one. All right. So we just have a package .json file, doesn't have any dependencies. Again, as always, I'm gonna set my font to 19 so you can see it properly during the tutorial. And I'm gonna create a file, so we can go here, right click and go into new file, or we can go here because we're in this directory, and we could do touch git ignore, right? So that creates an empty file with that content, and we can put the contents of the file here. We could also have done the nano git ignore and directly edit the contents of this file. So I'm gonna ignore git models. That's at least one thing that you have to do in Node.js projects. And next we're going to let me go to the live stream code just to make sure that we have what we need in place, and we'll go to the live repo, so github.com/nonoesp/live. We're gonna look at this project just to see TensorFlow.js predict pix2pix v3. All right, let's actually, I like to get names right, so maybe we can do, well, we'll leave it like that. All right, so what I wanted to take a look at is the dependencies on this project, because they're going to be the same ones. We just have TensorFlow.js for Node, and I guess we got TypeScript outside, so we don't really need it here, but it would be good if we install it as well, so we don't okay, it's okay. So what we're gonna do npm install, and we're gonna save. We're gonna install here TensorFlow.js Node, and I think for now that will be it. And yeah, I think that's all we need right now. All right, I don't think we have types for this, right? Those might come automatically there. Yeah, I don't think we do. All right, so we have some code from last week here on TensorFlow.js, some of the things that we might need. But the first thing I'm gonna do is I'm just gonna go here on my Visual Studio Code project. I'm gonna make an index.ts file, which we could actually directly call classify, because we're gonna have two commands. So we're gonna have classify, and so we can actually create classify.ts and search or query.ts, right? So here we remove this one, and let's go to classify. So import everything as tf from TensorFlow tf.js node. And the first thing that we can do, so I'm gonna use some code from last week, not to take too long. Actually, not this one. All right, so we're gonna start by loading TensorFlow.js, and we can actually print that we have loaded that function. So we can go down here, and we'll just see that our dependencies have installed. So we install 129 packages, and now we can go into here and take a look at our login. So we do down here, we do TS Node, which I have installed globally. If you don't have TS Node, just make sure that you do this. So you install TypeScript and TS Node, so we can, as we put here, JavaScript code, right? With TS Node, you can also do TS Node, and then you have the same runtime but in TypeScript, which allows us to do typing. And if we do that, we see that it's a constant, and actually we can define also, for example, let be string type nono, right? And this is a string. But if I now try to put a number, it will complain type number is not assignable to type string. So we're just using TS Node today, right? And if you want to install it, do npm install global TS Node TypeScript. Don't forget the -g to install it globally, otherwise it will just install in your current project. And here now we can do TS Node classify.ts, and that's going to execute our script. So it's going to hopefully load TensorFlow.js, right? So that's loaded, and it's loaded not TensorFlow.js, but TensorFlow.js Node, which is a special version that you can also only use with Node that uses part of your CPU that doesn't get used when you're running on a web app. All right, so we have Node, and one thing I'm gonna do today, so we don't take too much time on the part of loading the model and serving and all that stuff, we're gonna load the model directly from TensorFlow Hub. TensorFlow Hub is a repository, an online repository that the TensorFlow community or the TensorFlow team has put together for us to be able to get a new model loaded just like this with a few lines of code. And there is a huge repository so we can see the models. And what this does is that it allows us to load ResNet or MobileNet or other image classification models super quickly on our project. We don't have to download it and put it there. So task, let's see, these are all image classifiers. So this is EfficientNet. We might want to try that one. Collection. Let's image classification feature extraction. Train on ImageNet. So this will allow us to classify normal models. You can see that as we go up on EfficientNet, so from B1 to B7, the image size goes up, the model size goes up, and everything slows down a bit. But for now, we're just going to use B0, and hopefully we can get doing image classification really soon. So copy URL, download. We can download the model. Let's see what that looks like. It's a tar file. All right. Anyone that is online has any questions, has any comments? Okay. Cool. So this is a TensorFlow model, but for TensorFlow core, right? So you see the PB file. We could try to convert it. We have a, there is a video on YouTube. So convert TensorFlow JS. No. Let's see if we can find that video that way. Yeah. So these two videos right here is how to convert pix-to-pix models to TensorFlow JS. Really is how to convert Kera's TensorFlow core models into TensorFlow JS, and this other one shows you how to use it. We're going to do something similar today. And one thing we can take a look at is the formats in which this is available, right? So this is the URL. So let me see. This is TensorFlow EfficientNet loading, and this seems to be just for TensorFlow saved model. All right, so that tells us the format, and here is how you can use it on Python. It seems just with TensorFlow Hub, and this is also, this is also really interesting because that means that we can also use models that are remote, loading the Keras model with TensorFlow, not only with TensorFlow JS. All right, so let's go back and try to look for an image classification model that is available for TensorFlow JS, and we can actually use it today. All right, so let's go back here, image, and down here, okay, so I missed this part. So we can do TensorFlow 1 or 2, and also TensorFlow JS, TensorFlow Lite, and Coral. So we're gonna click on TensorFlow JS. We just want to filter by whatever is available for us to use today. So we have MobileNet, as I mentioned before. We have ResNet, V2, 50. All right, so feature vector, MobileNet, SSD, feature vectors, object detection model, and we just want image classification. So feature vector, ImageNet, ResNet, classification. All right, let's try this one. So let's try this one. It's compatible with TensorFlow JS. Right. All right, and this gives us some code that we can directly copy, and that loads a TensorFlow graph model for us. So we can hopefully directly do this. So we can do here, let model be this. I don't know if this is asynchronous or we're going to be able to do it like this. We will put this here. So let's actually, you know, we cannot see anything. Put this here. All right, and we'll log the model here. Let's first try to do this before we do anything else, and we'll just try running that here. All right, so we are just loading TensorFlow.js node, loading the model, and now logging the model there. All right, so promise pending. Cool, so that seems to be a promise. We need our await as async block. So we can do our async block here. All right. So let's just write it. Okay, so here what we'll do is we're gonna do here an async function. So we just run this here, and we're gonna put our model, because this load graph model seems to be a promise function in JavaScript. We'll just put here await. So we wait for this to execute before we log the model. All right, so again, we're gonna load 1, 2, 3. So we're gonna load TensorFlow. We're gonna try to load the model from TensorFlow Hub, and then we'll print the model. And later we can ask for the model summary as well. All right, I don't think I ran that. Cool, let's see. Right, doesn't seem like it's printing anything at all. Might that be working or not? Okay, so what we can do is do here model summary. We probably have some sample code on the website. Graph model. All right. All right, let's take a look here. Okay, sample using TensorFlow.js hub model. Let's see what we're missing. And also I see that there are some more people connected. Feel free to say hello in the chat and tell us where you're connecting from. All right, let's see. Okay, so we put here loading. Let me just put this here. Loading model from TensorFlow Hub. All right, let's try this out. Right, so the model is loading. All right, cool. I don't know why that didn't work before. So this is our model. So it's a graph model, and now we just need to get an image file and pass it through the model. Okay, so we're gonna keep running this classify thing when we continue. So, all right, so we have here this code, and later when we load the model, so we can say, okay, model loaded, and we could comment here classifying. And then here we could say something like done and print the classes as well. All right, so we need an image, so we need to get an image that we're going to use for classification. I think we have some here, right? So we have some images from last week and from the week before. Maybe image, so I don't know, like dog. Let's just get some images from here. Okay, so let's just download a few random images from the classes that we set before. Okay, some elephants, maybe also a road. All right, so these are our images, and we're gonna put them inside of make there live 32, and we'll open that. So we put these images in there, and we're gonna make a shortcut during okay, so we keep going. So we have a few images now in here. They're not the input size that we need, so we could force resize them. So let's say we get resized, so maybe 224 by 224. I'll explain. So if we go to the page from which we got the ResNet classification model, this actually doesn't tell us anything about the model, but let's actually print it again. So let's actually run our algorithm once again and take a look at how like the layers of the model. I don't know if we're going to be able to see anything from there, but hopefully we do. So classifying, so doesn't say what the size of the input is, but does it say here? Yeah, well, I mean, it says here that the size is 224, 224, and RGB, 3 channels with a batch input shape. So the thing that we did last week should work. So we can, to make sure, I don't know if we need to resize the images. Okay, so we have some code here to do that. So we can load the images from disk. So we're gonna copy what we had, so we don't have to redo everything now. So we're gonna copy, let's actually copy almost everything, because we kind of build on top of last week's code example. So let's make this a bit smaller now, so maybe size 15, and so paste this below. Right, so we now have this thing here. What is that? Okay, raw. Cool. All right. Okay, so we have the example from last week, and we're gonna put this thing here. And we need to copy, so we need to copy now the code for to load our model. So it needs to go inside of the function here where we were loading our model locally last week from pix to pix. And what we'll do now is that we're going to define a variable that is the model, instead of a layers model, is a graph model this time. And we don't print the summary because this model doesn't have a summary. I don't know if there is a way to see how the model is, but we'll load a input image and we'll assume that they are the size that they have to be. So now I have to resize this one. So let's try with Mogrify. So if I do have these images here, let's say we have them here, right? So you see their sizes. So they're like not 224 by 224, and I can do Mogrify. Let's try to do the PNG so we don't destroy this one. So resize to 224, 224, and we want to do that with all of the JPEGs, right? They're all JPEGs. Let's try that. Oh, not found. Okay, so these images are 224 in width, but not in height. So there is something, I don't remember the symbol, but we need to force the, okay, yeah, so that was it. So we put the arrow bank, so the bank here, the images get squeezed, and now we do have a 224 sized image, right? And these are all of these ones. So we're actually going to remove all of the PNGs in this folder, and we're going to run that command again, but we're going to leave the format being JPEG. All right, so now we have our data set as square images. So let's see what our data set looks like, right? So these are really small images, and we're going to start working with them. So let's see, you know, they're download from download, let's say 0 to 11. Let's load this one. So let's try to get the path for this one, and we're gonna put the input image here. It's gonna be download 0, input and output. We're not gonna have a save path because, you know, there is nothing to save so far. But what we could do actually is this could be, you know, we're gonna get a JSON path to save the JSON later. So we're gonna change JSON for JPEG, or maybe even just add the JSON format at the end. This is here. There are a set of helper functions that I don't intend for you to understand right now. Everything they do is read an image from disk and make them available as a tensor or an image byte array, just as an input tensor 3D that we can use inside of to pass through our model. And hopefully it is the shape that we need, because I'm not sure if this was doing that. So first, let's actually do here. So if we do input batch, I think we might be able to do shape. And you know, we're going to comment out everything here because we don't need everything that is in there. So first, let's verify that everything we have so far works. All right. Cannot find model JPEG.js. All right, we didn't install that one, and I didn't tell it to install it. So we're gonna go back to our live 32 there, and then we're gonna do npm install, save that one, and you know, that just installs that library for us. We go back here, and hopefully now this works. All right, so loading input. All right, so we actually have or get for free the input at the size that we want. We could see how to resize it later, but you know, because we've resized them manually before, we don't really need to do that. So that's good, that's great. And so let's keep going. So now we need to predict. There is this weird thing that I did last week where we needed to run model.apply instead of just model.predict, because we required a custom configuration parameter that was training, but we don't, and we can't even do that this week. So what we need to do here is that our prediction is going to be model.predict, right? So we're gonna do model, let's see, execute the inference, right? Let's just wait. So can we do this? Does this exist at all? Execute the inference for the input tensors. Input, so you put a TF tensor, and if you have a config, blah, blah, blah. All right, so my input is my input batch. Can I do that? All right, so I can do that. I have to await, and this will be my prediction. And hopefully, so this returns a TF tensor as TF tensor. All right, let's try running that and see. So we're gonna put here our prediction. And again, we're gonna see whether this works or not. Okay, so are you guys following? All right, so we have our prediction here. So we have a tensor that has a shape of 1 to 1001. So that means there are like 1001 classes inside of the ImageNet challenge, I think, or at least on this one that we've trained here. We can see, maybe it says here. Yeah, so we can see that the number of classes is 1001. So we're gonna get a set of predictions for each of those classes. The input images are blah, blah, blah. All right, and hopefully that is working in some way. In principle, consumer demand can fine tune it by passing trainable true to have kernels, the momentum, blah, blah. All right, that makes sense. So we're classifying that image, and now we need to see how to get the predictions into words. So to actually get the list of things that we're predicting. All right, so we have our prediction. Let's see how this is printing, loading input. So we have this here, log. So we're gonna log these things. Right. Cool, so we're loading our input and we predict. So we predict there, input batch shape. So we have the shape there, we don't need any more. And then we're predicting, so we can put a space here and like a line jump. And what are we gonna do now here? So we had some stuff here from last week. Let's see if we can get the how was this? So it was output, await, prediction, array sync. Let's take a look at this. All right, once more we're going here. I don't know if I can customize the size of the font of this terminal. All right, so this seems to be like a set of predictions. These seem to be the logits. We need to convert the logits into confidences, probabilities, right, from 0 to 100. logits to probability TensorFlow JS. Let's try to see out probability of prediction in TensorFlow JS. Logits, TF softmax logits. All right, maybe argmax. All right, yeah, cool. So TF, then if you wanted to get the index of the highest probability data sync, all right, so let's try that first. So we have the TF softmax. So we do, all right, so this would be to get our probabilities. So again, I know that this is going to be hard to see the entire script, but right now what I want is for you to be able to read the code. So constant probabilities, we gotta do TF softmax, and then I guess just pass our logits. So we're gonna call things by their names. So this is our logits, and we could have them here, but we don't want that. So probabilities, and all right. So what we're going to do here is we're going to get our probabilities, then we get we get the logics out of the model, that are some numbers that look like this, right? So look like what we printed here before. So these ones here, so these are the logits. It's a scale that I personally don't understand at the moment, can't explain, but hopefully we can see that in the future. So we get the logits and then want the probabilities. So logits are kind of numbers that go from minus stuff to plus something, and we want to actually get the probabilities, which will go from 0.0 to 1.1. 1.1 being 100% sure that your image is of a given class, and the other one is 0%, right? So with the probabilities, and probably here we need to do our await probabilities array sync, and we could print that. So let's take a look at open settings. So this is the editor font size, but do we have the terminal? Terminal. Terminal line height. Debug. All right, maybe. Does that work? I'm not sure. Well, I changed the debug console size, but not the output or the terminal font size. All right, so let's try to go back to the settings, and this, this is something we could take out of the tutorial, maybe like put as how to change the font size on Visual Studio Code, but this is not part of the tutorial. Integrated font size 20. All right, nice, great. This is really cool. Really cool. Okay, so if I do here font size, I guess I'll just get the font size of everything. So we can change screencast mode, controls the font size of the screencast mode keyboard. What is a screencast mode? Visual Studio Code screencast mode. Huh. What? Toggle screencast mode. Oh wow. All right. So this is what it is. Okay. Nice diversion. Okay, so debug font size. Let's just leave it maybe at 14. Okay, so cool. We have now the size of our terminal here is big, so that's great because now we can run these things. And we're gonna try to run this and see. So we'll load our TensorFlow model. So load TensorFlow.js, load our TensorFlow model, and then predict. And we get a set of probabilities, right? These are really tiny numbers. You can see that here, these are one of the biggest. These are 0.00002. Here we have really small numbers, but there will be some number in those 1000 digits that will probably belong to the class of object that the network is telling us that this is. So for that, actually, they have this code in there. Did I just delete that? Which we have here, right? So once we get those probabilities, right, we can get the results, which is getting those sorted or get by the maximum arguments, right? All right, argmax. So we'll do here const results tf argmax of our probabilities, and then we'll do data sync, and then we'll do get 0. Well, let's print everything, right? So we don't really need to do this anymore here. We can do here results, and I guess we can await here. Let's try to print that. So results. All right, let's do that. So we run this once again. So here, we're predicting, all right, so argmax. Okay. Not sure what's going on here. All right, so while this is getting done, so let's see result 1. All right, let's see if this works. So what? All right, result 0. Json Parse. Okay. Let's see. So we're gonna read a bit of the documentation here in case that they're giving us some hints. So this model is based on this. Using TF.js converter. And here we can see that logits, the output is a batch of logit vectors. The indices in the logits are 1000. The mapping from indices to classes with class 0 for background, followed by 1000 actual image classes. And this does right. Common image input conventions. Right, gradient tape. Which version? Okay, so let's try. So here we have this one, right? copy URL. We have this URL. Yes. Okay, so let's try to see logits to probabilities. Let's try to see that one. Argmax. I don't understand why we're not getting the right thing, but anyways, let's see. Tensorflow JS. All right, bear with me. We're gonna remove this from the tutorial, but this is just a quick search to figure this out. Not sure. There should be some code samples with at least with the TensorFlow core version, right? And these are the ImageNet labels that we're gonna have to use later. So with logits, target output. Maybe 0. I don't know. Right. Predictions 0. Right, might that be the problem? Let's see. So probabilities. So we have the predictions. So predictions 0. Right, let's actually print this back. So logits. Let's copy this one. So logits, data sync. We're gonna print that here. Wait. All right. One more time. Let's see. Let's put this here. So we have here a roadblock. All right. So that is our float 32 array. And I guess we have that for each item on the batch, right? So that's why they were putting the 0. So let's see if this works as well. We might be just trying to do the argmax on a batch of logits, not on the actual logit of the first image, which was, it's probably and hopefully what is happening. All right, cool. So this is, data sync. Not sure. So this should be, if it's an input TF rank, maybe. All right, so we're still getting the same thing there. So we have the erasing, we get the first one. And do we get anything with this? So await, probabilities, data sync. I have a bit of a hard time all the time when I'm trying with these things. I don't think the API is really intuitive in terms of syncing the arrays and the data. But yeah, I don't know, might be just me. So my alone, as I mentioned, isn't just supported. Login was a rank 2 and dimension was 0. Right, so not sure what that means. Argmax. So these are already the probabilities. Those are the probabilities. It seems like it's working. So what about so we have the probabilities, right? And we can print them this way. So we can do here this. So those are the probabilities. And now we could do, to log the results, we'll do wait tf argmax probabilities data sync. Let's try that one. Yeah, I don't know. I mean, there might be something different that we're doing here, but it doesn't seem like it. All right. 180. That's the first label that we got so far. And I don't know what I was doing wrong before, but let's just recap for the video so we remove the other parts. Right, let's a bit here. So let's a bit clean up. All right, so in the prediction section, right, so we'll be predicting, so we're going to define the logits variable, that is what we get out of the model, and we're going to call model.predict with the input batch that we've defined up here, and we'll await. So we have that logits variable allocated before we move on with the code, and then we're going to define this as a tensor. We'll just leave some space on the terminal, and then we're going to get from those logits the probabilities by running await.tf_max, passing those logics, and then getting the data. And then we're going to log the argmax of our probability, right? So this is our result. And what this means is that we're going to be getting first the logits, then the probabilities, and then we're going to get the index for the highest probability, which is 180. here we have a list with all of those 1001 categories that this model is going to classify for us. So if we put that here into this file and go to line 180, I'm curious to see what that is. All right, so 180 is a Weimaraner. I don't know even how to pronounce that. And that is a dog. Which, you know, if we go to the image that we're labeling or classifying, that might indeed be a dog. I'm not sure if it's from that class or not. So the image that we're classifying is this one, which might be a bit odd. So let's take a look at those lists. We also have a Staffordshire Bull Terrier, which might be more what we are classifying. All right, so it actually got it right. So I think the indices might be a bit shuffled, maybe, I'm not sure. But let's try with the other images and try to see, right? So if we classify all the images there, so we're going to do here a list of images, hard-coded for now. So we're gonna put all of these paths here, and we'll just hard code the paths as I said. So repos, live, 32 images, 224 by 224, and download. All right, so those are our images, and what we're gonna do, we're gonna leave this aside for a second. So what we're gonna do here is that an image paths will read the images into an input batch. We're gonna do this a bit badly, let's say now, but you know, let's see what comes out of here. So for and I need to look. Right, so for let, I'm looking here, I'm cheating. I don't remember TypeScript. All right, let's take that out of the video. For let image of images, so we'll just log here the image path, right? And we're going to do that really quickly without loading anything, not even TensorFlow, JS. Well, it seems like we have to do that. Okay, so we just keep the model loading and take a look. We just comment everything out here. And we don't need this code today, but let's leave it. All right, so we run this again, and cool. So we have all the paths of our images, and now what we're gonna do is go image per image, loading and predicting. So we're going to put this here and move all this code, and now we have that image path. So image block scoped before its declaration. All right, so this is an image path, right? So we'll just put the image path. All right, so for each of them, we're going to put a label, and what we're gonna do is, maybe we don't want this path here, so we can actually remove it. Well, let's actually make sure we copy first. So there is this, and our, all right, so we're just gonna have image names, and here in image path, we'll actually put image path. All right, so let image path. So image path every time is going to be the there and the actual image path. Okay, so here when we get the result, we can say and that. So we do here image name, which we're gonna name right now. So image name, and then the label is result. Let's actually do result plus one, just see if what I said before works. Result. All right, we won't do this right now. Cool. Okay, so we have the result there, and now I think, okay, so we're not loading the model, so that's gonna fail. All right, so we'll load the model here. So constant image path, and all right, so now we're going to load our model. All right, load TensorFlow.js for Node. Then we'll load our model from TensorFlow Hub, which is ResNet v2. And now we're gonna start predicting on each image individually, and later we'll get the strings from that file that we had before. All right, nice. So these are our predictions from what each image contains. And so we're gonna clean this up a bit. So here, so loading input, predicting, and then there. All right, so we have a list of tags here. So we're going to save them to the same folder. So image, what's the original file name? ImageNet labels. All right, so let's use that one. So imagenet.txt. So we need to read that with fs. So fs read file sync, and I think we can get the content. All right, so all right. All right, so we're gonna get the contents of file with a read sync. So okay, so just put here the UTF, so what we want to decode it to, and this would be so constant labels file. Maybe we don't, in case we use this for other models. So let's put it for now like this. So ImageNet labels.txt. So this is our labels file, and we just put the path here, file. Cool. And we can actually, let's try this in TS Node first. Right, so import, so const fs require fs, so we have fs, and now we right, let's just try that one. Okay, so we define the labels file, we now get the labels, and now we print the labels. All right, so we have that, and we just need to do labels split by n, and then we have all the labels. All right, great. So this works. Labels, split that. All right, we can just add this here. We now know we have the labels file. So we just okay, we don't really need to do a function here. All right, so we just put this here, and now we have our ImageNet labels. All right, so we have our ImageNet labels. We can just call it labels. And when we print here, we can also do here, so labels result, and we just get that index. So this is a float 32 array, can be used as an index type. So maybe we do parse int. How about that? No. Oh, an array. All right, what about this? Wow, okay. So let's go here. All right. Cool. All right. So once again, we load TensorFlow JS for Node. We load our model ResNet v2. And now, all right, now we're classifying. Cool. So you see when we get the index, actually index 180 is line 181 because the line 1 is actually index 0. So we're getting a set of predictions here. And what we can do, just, I mean, and this is just for us, it doesn't really matter, but we're going to put here, so we're going to hide these statements here, and we're going to say predicting, and we're going to get a set of labels with their, you know, their indices, and we're going to format this in a way that makes a bit more sense. All right, again, cool. So for the last time, or not for the last time, but you know, we are loading and now classifying with the model. So we predict, and then we get a label here for each of our files, right? So we have a folder here. So we have download 0 is a Stanford Bull Terrier, Pembroke, Tree Frog. We have a bee eater, a tiger, and this is a bee eater. This is a house finch, African elephant, trailer track, well, warplane, planetarium, and then forklift. All right, I mean, not perfect, but I think it works. And now everything we need to do is go to part 2 of our list. So we've classified image with TypeScript and TensorFlow JS, and also ResNet v2, ResNet 50 v2. And now we need to save the labels as JSON per image, and then we'll query images by label and confidence. I don't think we're gonna do the one by confidence right now, but we could, you know, we could add that next week. But so what we're gonna do now, we're gonna go back to the code, and now we have here also the FS write file sync, and we're gonna try that really quickly here with our TS Node environment. So if we want to save, so for example, let's say at users Nono desktop file txt, and I want to put here so contents, does that work? All right, so here we have a file that has the contents, right? That works. So we could say that this is our JSON file, and we put here property that's called labels, and it's gonna have, like, for example, tree frog, right? Something is wrong there, so this should be actually a thing like that. All right, so now we've written this file that has JSON on it, right? All right, let's kind of scroll back and go do that on our actual code. So we can remove this stuff, and every time now that we classify, we log our prediction to the console, and then we save JSON file with top prediction, right? So what we're gonna do first is we're gonna construct our JSON, right? So prediction JSON, and it's just gonna be a labels array with our top prediction, right? So we're gonna get our, so let's say top prediction equals that, and we just get here our top prediction. That's going to be the only element in our array. And then what we do is that we do fs write file sync, and then we need so image name, so we need a JSON name, and then the contents is going to be JSON stringify prediction JSON, right? So we convert the JSON that we had here into a string that can be written to a file. And for our JSON name, so JSON name is going to be or even better, so JSON path, right? So we go for JSON path. We're just going to get our image path, and as we did before, we're going to replace, or like we're going to split the JPEG part and then join. Was it? No, it probably just replace, right? Well, I mean, you can do both, but we'll just do replace, and then we'll get the JPEG part into jpeg.json, and hopefully that works. So we're going to complete, so we're doing right now part 2, so save labels as JSON per image. So we're going to clear, and now you should see that what we've been doing so far is just to obtain the label that the system gives us for each of these files, create some JSON with it, and then save those files to disk. And it seems that we got a successful result. So we can see that for the first file, we get labels Staffordshire Bull Terrier. And, you know, if I go down, we get the Pembroke, Tree Frog, a tiger. You know, we're getting the different labels that we saw before, right? And ideally, we'll put the label and also the confidences, so the probabilities, and multiple labels, not just one. But for now, you know, let's keep it simple and do it that way. So we have completed phase 1 and phase 2, and now we need to query images by label. How do we do that? Okay, so we're gonna try to query at least one image, and for that we created before the query.ts file. Here we just need to do our you know, we just will define fs as require fs. So this is the file system library we use to load files. We're gonna hard code this right now, so the directory is gonna be this one here, so we have it on the other folder. So this one here, we could put this as a function argument, but for now we'll just leave it here. So config and dependencies, and we're going to now want to iterate through folder contents, and then read file contents in search of query labels, right? So our query is going to be for example tree frog, let's say. Iterate through folders. All right, so how was it to list Right, so first let's try to execute this one. So now we're executing search.ts, no, query.ts. Query.ts. All right, so we get an array with the contents of that directory. So this is like files, and we're getting the names for all of the files, right? So we just want the JSON ones. So we can now do for let file of files, and then we'll say if file.split.json length is greater than 1, we'll log that file name. Read file contents, insert, and we'll do that here. All right, so great. So now we do that again, and what we're doing, we're just getting the JSON files right now. All right, let's pause the tutorial for a second. I see that there's some more people connecting online, so I would really appreciate if you can tell us where you're connecting from, who you are, what you're looking to learn from these videos, and any thoughts that you have on what we're doing today, on any videos or any podcasts that we've done previously. Welcome to the channel, and thanks for being there. All right, let's get back to the tutorial. So we're just getting JSON files here, and we've managed to do that by doing fs.readDirSync. We're getting all the contents in the directory that we're inputting to this script. Now we iterate through each of those files, and we say, okay, look for the file names that have JSON on their file name. That way we exclude all of these JPEGs that we have on that folder, and we log that to the terminal, right? So we now know we have the right files. Now we can do our JSON would be, if we do fs read file sync, we read that file, which we need to actually construct the file path, which is at the directory and then the file. That is actually the file name if we want to be a bit more accurate. So we can replace that with file name, and then we'll read the file synchronously, serialize to UTF-8 and get the contents. And well, let's actually see that, right? So we have the file path and we have the JSON, so we can log that to the terminal. So here, for each file name, we get the path and then we get the JSON, right? But it's a lot better, or a lot prettier, if we, instead of doing that, we do Json Parse. So we try to parse the JSON that we serialized to string before, and we log that. So now we're gonna get actual JSON objects that when printed to the terminal, right, are a bit prettier. So this is great because in our series, right, in this tutorial, we actually went from classifying images to saving labels as JSON, but now we're running a completely separate script that is trying to look for that database that we've created with those JSON files on the disk, right, on the file system. So we're going to go back to our code for the last step, which is, here inside of the JSON, we can just print the labels. We don't need to print anything else, and we can print the first item. We know that all of our items have at least one label, right? So we read the files, the contents, get the first label, and here they are, right? So a really dumb way of doing this, right? If we were to find, right, so this is our top prediction, right? We have that label, and now what we need to do is say, if our file name contains that top prediction, we just return, right? So we can say found image with found image of top prediction, right? And then we can do here break, which will stop this loop because we've already found an image, right? So we can do this, and now we don't find anything. All right. So why is that happening? Let me see. So we have this console log break. All right, let's log here the top prediction really quickly. All right, so the top prediction is loaded there. So we have tree frog, right? So the file name doesn't include that. Okay, so it's actually the top prediction needs to contain our query, right? Not the other way around. All right, so this should work now. So we're looking for frog and found image of tree frog. All right, so now let's make it easier, right? But what we can do here is say, okay, looking for an image of our query, right? So now we could put here the actual file name, right? So now the script is saying, all right, you're looking for an image of a tree frog, found the image of a tree frog, right? So if we do this, awesome. So let's just take one more look. Great. So what can we do now, right? So that is not the file name. It's actually, if we go back, we'll do here replace JSON with nothing really, and do that. So we get the actual image name. Oh, no, we actually want to remove it. And now we could open it, right? We could actually open that file. So how can we do that? So shell, so npm shell.js. All right, so we can actually do here, so live 0032, we can do npm install shell.js and npm shell.js. So we take a look at the shell.js API really quickly to be able to run like a terminal command from our script. So we're gonna, all right, so we add here const shell equals require shell.js, and that shell.js is gonna allow us to do exec, right, to execute a command. And we're going to add it here. So we're going to actually execute a command just to open that image, right? So we're going to put this here. So match path. And we don't have that variable, so we'll do match path equals, again, there. So this is our match name, and we'll put that here. So match name, match path, and that's one first step. So we're looking for tree frog. All right, and we found tree frog. So let's hide this one here. And then the last part is like npm args. Is it jargs? Maybe it's jargs, the one I normally use. So this jargs library, I think, is the one that I was using before, or maybe it's args. I don't remember now. They look really similar. Arg, or was it argv? Any of this is gonna work. I don't remember. Hello Lourdes, nice to see you connecting. All right, so let me take a really quick look at something that I have here. that uses one of these libraries, so we don't have to reinvent the wheel. Okay, yargs. All right, so it's actually yargs. This is a winner. All right, so we do npm yargs, we install that one, and we just have to, oh, no yargs, not found. Oh, yargs. All right, so we put another dependency here at the top, so arg yargs, and we just have to add some parameters. So let's say we have our, I'm gonna put them here. So we're gonna have our query and our there, right? So we are, I have a default here, which, we're gonna use this default right now. I'm gonna convert, so this query here, so the default is gonna be tree, so like frog. And this is just really quickly what I did is we have we load yargs, and then we create two parameters, so query and there. The shorthand or alias for each of these is Q or D. Both are string. The description we're gonna add right now, so this is like query string to find image matches to search images, right? Search, so maybe image search query, and this would be like directory containing images to search for. All right, so we do that, and the first thing that we're gonna do is query, and how we can use those is we just do here argv dot, and then we have the parameters that we specify on the CLI, right? So that's really convenient. And to test that this works right now, so return, so we leave that there. We don't. Okay, so let's comment that out really quickly and just print arg there and arg query. So if we go here now, we run this, nothing happens, only the library dependencies get loaded. So now we can specify our there. So for example, users Nono desktop, and then that gets printed. Maybe not. And we have the query, which is, let's say, test. Maybe not. All right, so what is going on here? All right, so we actually need to put below here the argv variable. All right, cool. So now we have those, right? So if I change these ones here, you see that the parameters change. And we could also just simply print the argv array, I guess, and do that here. All right, so this is our query, right? So we have the query here, and now we can go back and use it. Arg, and okay, so now we're gonna do a real search. So we're going to specify this data folder. So we'll put our, so we'll do clear ts node search.ts. We'll have our d argument to be the path, and then the q to be elephant, right? So when we run that, I cannot find model. Okay, again, so that's not what it is. It's actually query. All right, so we run now ts node query.ts, and then the directory we specify with the D, -D is where our images are, and then our query, so the word we want to search for. So now we do this, and it opens the image that contains an elephant. So if we put here road, I believe there was one with road. Now nothing was found, so I think there might be something of well, frog we saw, and let's see, let's quickly run our classifier to see what images we do have, what classes. Cool. So again, like we could go back to our other command now and look for example, for tiger. And then we get the image of the tiger, or, you know, we get like warplane. And right now, you know, it's really simple. We're just returning the first image that we find with that, but we could do many other things, and that could be, you know, we could build a search engine, let's say, for our images, to search or to query the database according to the labels that the model has discovered, right? Has like classified. All right, so let's quickly go into the live repo and see what's in there. So we add OOC32 into our commit, and we do a new commit. So this is going to be like live32 add text to image Tensorflow JS sample, and then we push. So we push that to the open source repo. So the code is live in there. So we have that right here, right? So we have those nodes there. So this file, maybe we can move it into live 0032, and then here into text to image readme.md. So we go back to live, and its status, we git add 0032, and then maybe and push that. So now we not only have this, but have this readme, and now you have this the dependencies here in the package.js file. We have the query script, which loads TensorFlow, and then hardcodes a set of paths. We don't have arguments here, but we could get the image labels, so on and so forth, right? So we have some code here that it's not as clean as others, but you know, it does the job. So it saves JSON files with our classifications, and then when we query, what we're doing is just looking for a string inside of those arrays of labels in the JSON file, right? All right, so with all of that, I think this is it for this tutorial. And let me see if we can wrap there. We'll remove, did we add anything here? Right. Okay, and let's remove this part from the video, and let's make a quick outro screen. All right, thanks so much for watching. This was a sort of quick, hopefully, and light overview on how to create an image classifier with TensorFlow JS, grabbing a model from TensorFlow Hub. It was ResNet v2, ResNet 50, and classifying a series of images, and then saving a JSON file next to the images with the top prediction that we found. Then we built a query script, also in TypeScript and Node.js, that will iterate through those JSON files and look for a specific query in those labels that we had saved. That way we could query the images by the labels that we had classified previously. Again, thanks so much for watching. It was Nono Martinez Alonso here, and we'll see you next time. Bye. All right. All right. So don't panic. I think this was just a tutorial. I just wanted to make this exercise and kind of explain it from concept to actual implementation. I would like to ask, so Fabian, can you tell us on the chat what parts you think that were useful and what challenges are you finding on Swift UI? And also, can you briefly explain what you have been going through? So how you've trained the model in Core ML, how you've used it in Swift UI, some code that we can take a look at. And would you like to replicate a similar strategy in Swift UI? All right, so I'm going to put here quickly a break slide. I would really appreciate if you can take a second there to answer that on the chat, and because we're gonna be gone for a few minutes. I want to thank everyone who's watching. If you want to write on the chat or something, that I'll be open to discuss anything. And yeah, so I'm gonna leave this here. So I'm going to go take a quick break. Don't go anywhere, and we'll come back to wrap up a few things. All right, I'm back. So let's see. Sarper. All right. So it seems we have a recent member to the Discord server. So it's Sarper. Also Fabian, Code Anticode, Gokermu, Esa, Dalia. Welcome to everyone who's new. I'll invite you to introduce yourself, as many are already doing on the introductions channel. So we can all welcome you and know what your background is and what you're looking for with on the channel. And yeah, I don't really know why this just showed up here, but there it is. It's kind of random that this just got reshared here. All right, so yeah, I will say if Fabian wants to take a look at some code, I would be happy to take a look at it right now live. While we're waiting, if we can get that code, I'll go to Jose Luis's live stream because I just want to show you that he's live right now. So let's see if you can hear anything. All right. So I'm not sure if you can hear. I just muted the video, but this is computational design live stream is a live stream done by Jose Luis Garcia del Castillo. So some of you might know who he is. Oh, I might be actually over him. So let's just put the video here. So this is the computational design live stream. This is slowing down a bit. You're gonna like this video. And I will recommend you this channel, right? So this is the parametric camp channel, and he is right now recording a spree of tutorials all this week, and he normally records videos. That's a live stream usually on Fridays, but the schedule now is a bit different. Let's listen a bit.
This time in relation to points, for example, and it is the fact that if you think about this carefully, vectors are represented by 3 numbers, whereas points are also represented by 3 numbers, which means that at the end of the day, both are just 3 numbers. And the only thing that makes them different is how we, computationally or geometrically, how we interpret them. So one of them, we think of it as location in 3D space. The other one, we think of it as an arrow pointing in a particular direction with a particular magnitude. But in a way, since they're just 3 numbers, for the computer is the exact same thing. And therefore, a lot of the algebra.
All right. So I'll recommend you to check out some of his tutorials if you want to get into Grasshopper and some other things. And let's see if we're getting right. So for Duadet of Fidode, I don't know how to pronounce that, but welcome to the channel. Glad that you joined us. Feel free to introduce yourself. And for those of you who are who are not on the channel, I'll post an invite link to the Discord on there. So it should be, let me see, Discord GG, this is it. Maybe we can make a type expansion. So we do here, do we have links? Right, so we'll do here one that says Discord and put that link and remove this one. All right, so I'll put the link on the chat. So this would be Discord, and then you got it. All right, so we're getting a private message from Fabian here. I hope we can help too, blah, blah, blah. All right, so let's just save these images into our desktop. and go here. It's here links for live 32 apps. All right, let me just put a link to what we've done today on the live stream channel. Right. So honestly, I don't think we're gonna have too much bandwidth today to cover that, but hopefully we can do something here. So we can see here, so VN Corel ML request. This is really low res. Init is deprecated, blah blah blah. Image crop and scale, center crop. Let model request. Update classification classifying. Handler perform. Handler VN image request handler. So it seems like passing an image and orientation, and then we're doing that. So we perform a classification, and then here process classification. So results, unable to classify, nothing recognized. And then here we're mapping, and then we have the classification, top classification, and we have the confidence and the identifier. And here we have all right, so and this is Core ML for those of you who don't know it. You know, I don't know how to help right now. I think it would be just finding a way to create a local database on the phone or something, so you can have the classification of all the images, or maybe just go image by image classifying with a query without having to save the files. So I guess like both things would work. I don't really have a suggestion on how to continue with that like right now, because we don't, you know, we don't have a lot of time to go through that. I would love to go through Swift UI now that we have gone through this example. So maybe at some point we could at some point we could look at that on the live stream. I'm only doing live streams right now on Thursday, so maybe next Thursday I could do that, but we're not going to be able to do it today. We can continue on the, you know, on the Discord server. There's like a lot of exciting stuff there, so we can take a look. But yeah, I hope that was useful in some way and help you, Fabian. All right, so we're going to wrap this up now and just check the thumbnails, schedule live stream. I'm gonna do this offline, honestly, because this takes a lot of time when I'm live streaming and doing that stuff. So yeah, no reminders really. I will just wrap up here. Thanks everyone for watching, and it was my pleasure to do this live stream. I don't know how long it's been, like probably almost 2 hours or more than 2 hours. I'll remind you to like the video. This is a really good way to support the work that I'm doing here on the live stream for more people to get to know about it. And do subscribe. So if you subscribe and click on the bell, you'll get notified when I go live next or when I upload new videos. You can join us on the Discord server if you haven't done so yet. And yeah, thanks so much, and I'll see you next week, hopefully. We'll be uploading, so I'm gonna take this brief time. So we finished now, so the live stream is done, but now we have some time to play. So if we go to Getting Simple, right? So this website, we have new episodes, you can go to view all, and we have the Bytes intro episode, an interview with Luis Ruiz, and many other episodes. As always, because we're looking at machine learning here, Adam Menges' episode and Cristobal Valenzuela's episodes are really interesting. They're the co-founders of Lobe.ai and Runway.ML, so you can start with those episodes if you're interested. We have a really neat interface, I think, or at least I like it, on the web, where you can, you even have a web player here. So if I have myself, you can see that, or maybe I put myself on the right, you can see the web player here, right? So you can click it and listen there, or you can go to Apple Podcasts, Spotify, or YouTube. And we're gonna release this interview as an actual video recording episode. So this is sort of an announcement. This is going to be the first ever Getting Simple episode to be released on actual video recorded with cameras, not with webcams on remote meetings. And I will really encourage you to take a look. And you can also, some of you have already sent us questions at, you can go to gettingsimple.com/ask, and you can click on the recording button, and you'll be able to send a voice note. Let me grab something really quickly. Right, I'm still here, and we're gonna try to load something so I can show you. So I can show you here. So where is this? Really quickly. And all right, where is this? I want to show you. It's gonna be a second. All right, so yeah, this is it. So I can actually leave from here, right? So this is a take of that interview. So this is kind of a teaser from that, and we also have this other one, right? So these are the two shots that we can see so far. And you can expect to see this on YouTube pretty soon, and I'm excited for that. We had to wear masks, but I think it sounds really good. I mean, the sound is similar to the one on the audio podcast, but it's going to be released in 2K, and I'm really excited about it. All right, so what else can we take a look at before we go? So the Getting Simple podcast, and also that you have a bunch of new tutorials here. So we keep uploading new videos and editing. So all of this is new from this week. There are going to be videos dropping, even I think in like 30 minutes. They're going to be the follow-up of this style gun video. We also have a new well, I have a new thumbnail generator that I'm not going to show yet. I'm working on it, and it's letting me do all of these awesome thumbnails. And yeah, I don't know. I mean, there is a bunch of stuff. If you want to see it, you can go to the playlist section, and you can open the web development playlist. There's a new playlist for Runway.ML, and a lot of other videos are inside of on the machine intelligence playlist. So we can go here, we can see, so the web, so new videos are going to be dropping here. You see some of them are already here, but they're hidden for everyone else. And the same applies to the ones with machine learning. So we'll see some of these dropping here over the next days. So we already have a bunch of videos online. All right. Once again, this is Nono Martinez Alonso. I'm really happy to get together with you to code one more week, and I will see you next time. Bye, everyone. Bye. Thank you.